welcome to an exciting prime on 5G. The course is powered by 5G Courses, top of the market in providing 5G courses globally. So I'm going to be your personal instructor over the next hour or so. And the way I have constructed the course is to make it as lively and applied as possible, whilst not losing oversight of important technical challenges and achievements. Now let's start with me showing something very few people have seen so far. So one of the world's first working 5G systems right here with me at King's College in central London. I'm standing here in front of the Bush House, which we moved into from the BBC used to be in here. I'm walking now through the reception area at King's and walking now through the barrier security, getting into an elevator and going up to the 8th floor where we have our coffee shop. And that's where I'm taking my coffee every morning. And ladies and gentlemen, welcome to London. On the roof of London, we're seeing here loads of very famous monuments. The church you see there in the background is where Hans Zimmer recorded his theme Interstellar. So that is the church you see here. And I'm zooming over now into London. So you see the Big Ben, which is wrapped there, the House of Parliament, the London Eye. For some reason, London only has one eye. Anyway, we're moving in now into the Strand building, and you see a massive MIMO antenna there and a millimeter wave. Well, you don't really see it, so I'm going to go now to the other side, and you see the squared antenna is a massive MIMO 3.5 gigahertz, and the other one, the small ones, are the 28 gigahertz. They're being front-hauled into the 5G engineering room in the cloud center. And as you can see, that is now not purpose-made hardware anymore. It is actually off-the-shelf cloud computing equipment, in this case provided by Dell. So we have a lot of opportunities here for 5G to become a very agile system, in that we have decoupled hardware and software. You can get your hardware from anyone you want, and you're implementing the software, whether you write that yourself or you get it from any of the leading vendors in the field. Let me show you an exciting application we did here. And before I explain you what happened here, let's listen to the actual song. Listen, so what happened here is that I'm playing the piano. I'm under the Brandenburger Tor in Berlin. And on the other side in London, in the Guildhall, which happens to be the oldest entertainment venue in London, we have this very talented, what I personally think, very talented singer helping us to perform. Now, she normally sings in the Royal Opera House, and very conveniently, she happens to be my own daughter. And we managed to get a latency of only 20 milliseconds between London and Berlin. Think about your sound card of the computer you're sitting in front of. Your sound card produces a latency of more than 20 milliseconds, and we managed to get a latency less than that across two different cities. And that is what 5G can do. But for that, you also need specialized codecs, video and audio codecs. But once you have done the whole design, you can do distributed concerts like these. Isn't that wonderful?
Welcome to this course on 5G. I want to start this with a very simple question, and that relates to your smartphone. How often do you really look up onto this little corner there where it says 3G or 4G and you check what network you're on? You almost forgot about it. You're not doing it anymore. The only time you look up on this little logo is when your connectivity drops from 4G to 3G, or from 3G, even worse, to 2G. And that's a really good signal, because telecoms has become commodity. We forgot about it. Wireless is like an Ethernet. It's just, something you don't think about anymore. Now, this course is going to be about understanding if 5G will push that type of perception even further. Welcome to our first session. There are quite a few important items we need to walk through. The first one is on the key performance indicators. I want you to understand what 5G is expected to do in the future. We then talk about some technology enablers. So I want you to get a feeling of what is really novel in 5G. What are all these exciting things the engineers talk about? And finally, I'll introduce you into the world of standards. Why are they important and how do they operate within the setting of 5G? Let's get going.
Now, the learning outcomes of session one, I would love to be that you understand the key performance indicators, the KPIs in 5G, appreciate the use cases, have a good idea of the tech is being used today, as well as have a good understanding of the 5G standards and procedures. And of course, enjoy my telco gossip, which I will give you at the very end of the course. Now let's come to the key performance indicators. And I always say, 5G is both very boring as well as very exciting. It is boring because it follows the trends we have observed over the last years as we moved from 1G to 2G, 3G, and 4G. Things always improved by an order of magnitude. Data rate always multiplied by 10 or 100. Number of devices increased. Criticality improved. Now, the exciting thing about 5G is that for the first time, it is so good that it can support a lot of the industry processes. So latency is very low. Hey, it's so low, I can replace my physical cable, my Ethernet, with a wireless system now. And this is what is one of the most exciting developments within 5G. Let's compare the 4G and 5G KPIs. So you see the table here, which 5G PPP produced. And I want to highlight three of these KPIs. So the user experience data rate. So we're not talking about peak rate. That's what you will experience in average. So in 4G, it's about 10 megabit per second. And in 5G, we want your experience to be 100 megabits per second, right? This is stunning. Imagine in average, you get 100 megabits per second. The user plane latency, that means the latency you get when you start opening a website or you start controlling things remotely. In 4G, we can do 10 milliseconds, and in 5G, we want to go down to 1 millisecond. And I'll tell you later how this is being done. So that is a huge challenge on how do you really diminish the latency. In terms of the connection density, in 4G, we can do a lot, 1,000 devices per square kilometer. Arguably, we can probably even do more. And in 5G, we want this to be millions of devices per square kilometers. So really upping the game by several orders of magnitude. And these are the 5G technical use cases we are thinking of. Think of it like a pyramid, which is shown here. On top is what we call the enhanced mobile broadband. It basically means more data to you as a consumer. If you before took maybe a minute to download your movie, well, hello, in 5G, you can do that in a few seconds. So we see that as a very, very strong technical use case because, of course, we have more and more data-hungry applications coming out. But we also have an IoT application here, which is on the bottom left corner, which we refer to as the massive machine type communication, where we have loads of IoT devices, low cost, long battery life, covering huge areas. And then we have the more exciting one and the really difficult one to do from a tech point of view. It's the ultra reliable and low latency communications, or the URLLC. No idea who came up with this abbreviation. And that is really about mission critical stuff. That is new. That is, think of an Ethernet cable being done wirelessly. So we are really trying to disrupt here heavy industries, which normally would rely on a totally different technology. Let's look at the spectrum. And 5G offers a very rich and a high plethora of spectrum bands. And roughly we have 3 bands which are new, and we call them the pioneering bands. There's one which is below 1 gigahertz, so this is typically around 700 megahertz. In the UK, that's the TV white space band. It has great propagation characteristics. So you put up one single base station, it has a wonderful coverage. Well, yes, because it comes from the TV bands, right? So TV needs to have a huge coverage in urban, suburban, and rural environments. So that's really great for coverage. Great coverage means, it's good for investment. You don't need to put up so many base stations. On the other hand, of course, you get a lot of interference from other cells because everybody can hear each other over very, very long distances. And there's not too much spectrum available, so data rate is never too good. But it's a great band to control things. All the real-time voice traffic can go in there and some of the video traffic as well. And then we have the 3.5 gigahertz range, and then each country, it's a little bit different, but that's a good band and a very prime location because most of our cellular systems today work on a band which is very close to that frequency, which means that all our planning exercises we have done, all the deployments we have done, we can reuse that for this frequency band. And the technology we want to use there is massive MIMO, loads of antenna arrays, and I'll explain that later. And then we have the millimeter wave bands. Now that is very new, that's pioneering, and it is something everybody is very excited about because we are using very high frequencies to support a very mobile scenario with loads of handovers and mobility. Nobody was sure if that would work really, but we are seeing now that actually the propagation characteristics are so much better than we thought. There isn't too much blockage. There is a relatively good link and the designs have been done really well. So we're excited about having these millimeter wave bands where you have a lot of bandwidth, so you can pump through tens of gigabits per second of data, downloading an entire Netflix movie within milliseconds. So these are the three bands I want you to remember: sub-gigahertz, typical cellular 3.5 gig, and the exciting new bands of millimeter wave 26 in Europe and 28 in the United States, the rest of the world. So what type of key technologies out there? There are totally new ways of deploying your stuff in the field, and this is highlighted in red here. We're talking about, device to device. Hey, suddenly in 5G, you can start talking from one device to another. I have to say, though, that in 4G, we could also do that, but we believe in 5G that becomes really operational. Then we have very, very dense networks. So we're able now to get a density which we have never seen before, and we can have so-called cloud run. So rather than having the processing done on every single base stations, which you would sometimes see on the roof, you have only antennas in there, and these antennas are connected with a fiber down in the basement where you would have a server farm, which I've seen on the video before, and that server farm would process essentially all the data you need to process and do all the processing. That's called a cloud run. So totally new ways of doing that. We have new physical layer technology, so massive MIMO. I alluded to that earlier. So this is about having loads of antenna arrays in a single base station as well as in the mobile terminal, because we figured out that asymptotically, as you go up with the number of antenna elements, you can get rid of interference. So we're talking about initially hundreds of antennas and maybe one day thousands of antennas. Who knows? Technology moves so quickly. And then we have millimeter wave, which works in the high frequency ranges where we have a lot of bandwidth available. But I think arguably the most exciting thing is actually what is highlighted in green. And that is a totally new way of running your infrastructure. So rather than being a business where we have boxes and cables, 5G will be a business which is all about software. And that means that if you want to implement a new feature, you don't need to send your engineer to do the changes and change the box there and do new cabling. You do that with a mouse click from your coffee table, right? And we are able to do that because we decoupled hardware and software. And that is what the network function virtualization achieves. We decoupled the control plane from the user plane. That is what SDN does. And that allows us to do network slicing, which I explain further down the road. So I want you to remember there's totally new ways of essentially using your deployment, new technologies on the wireless interface, but most excitingly, a totally new way of deploying your infrastructure and have a very software-centric view. Let's deep dive into this softwareization. So I said that's the biggest revolution happening. So if you look at this slide here, On the lower part, on the bottom of this slide, you see my actual physical infrastructure. So we're talking about computing hardware, storage hardware, and networking hardware. And you put a hypervisor on top, a virtualization layer, an operating system, whatever you want to call that. And that virtualizes my physical resources. So I can now suddenly offer virtual compute, virtual storage, and virtual network. You know, it's being done on the computer you're watching this course from. The operating system is virtualizing the hardware infrastructure so you can have many applications run in parallel. And that's what we want to do, right? And once you have it virtualized, you then can have so-called virtual network functions use whatever they need, right? So one of them may need 10% of the computing power, 50% of the storage, and 80% of the network. Hello, my hypervisor can offer that to the first VNF in the game. And this VNF might be, it can be anything really. It could be my entire core network. It could be just a security authentication function. It could be a handover and mobility function. So think of VNF, literally packages which have an input and output, and something happens in between. But it's virtualized. So it can use any resource it wants. It can be ramped down, can be ramped up, can be moved in the infrastructure because it's a piece of software. Of course, you need to manage that, and you have the VNF managers and the network function virtualization infrastructure managers on this side. Why is that important? Why is softwareization important? Well, hello, because 5G is not a single homogeneous technology. It is a whole set, a salad of technologies. Just look at this slide here. So many technologies out there. You got, totally new ways of handling IoT, Cloud Run, millimeter wave, ultra dense networks, vehicle to infrastructure project, etc., etc., etc. How do you manage that? There's no way you can actually deterministically program and configure that. Doing that in software to control everything in software and manage it is the only way forward. Who is who in the 5G standards world? You see two families here. On the top, you see the actual standards initiative, so something really global here. And you see 3GPP, which is really like the operating arm of all the telco industry. This is where we standardize all the telco equipment. That's the body which is responsible for you being able to make a phone call, whether you're in Sydney or you're in Los Angeles or you're in London or in Beijing, wherever you are. So that's 3GPP. The GSMA is an operator-led initiative, and it came out of GSM 2G, and they're pretty good in actually getting, the requirements for the system up and running. And so is NGMN. So NGMN is a purely operator-driven initiative where they set out requirements on what really drives essentially often the 3GPP and the ITU type of standards development. The ITU is an SDO, it stands defining organization, and they are setting out really what is 4G, what is 5G, what 6G will look like. And that's the role of the ITU. And the IEEE we are familiar with as well is another SDO, which is taking care of standardizing anything which is often in the layer 1 and layer 2 technologies. And then you have loads of associations, call them lobbying buddies, all over the world. In Europe, we have the 5G PPP, and you see all the other names here on the slide. I would like us to understand 3GPP a little bit better. So let's do a deep dive on how 3GPP functions and operates. So you have three stages, really, or three groups in general. So you have a project coordination group, which is a very high-level group, kind of the directors of the game. They decide what should be looked at. Then you have the technical specification groups, which defines then out of these high-level items, specific work and study items. It looks at, what's possible, and then it approves certain technical decisions, and that is being then put down into the working groups who actually do the hard work of defining the actual standards, how the protocol works, how the architecture works, etc. And once that is being finalized, it goes back to the TSG, and they are then approving that. That goes back to the PCG, who are then giving it the rubber stamp on that, and it becomes a standard. And these are the structures. That's the 3GPP operating structure. We used to have 4 columns, and now we have only 3. So we have the TSG RAN, so which is the radio access network, and you see the different working groups here. So RAN 1 is radio layer, RAN 2 is radio layer 2 and 3. Then we have RAN 3 taking care of the different interfaces, etc., etc. Then you have the TSG SA, which is the service and system aspect. So again, you have the different groups there. You look at, for instance, SA2, which is the architecture group, very important. SA3 is security. We also have codecs, etc., etc. And then we have TSG CT, which stands for core networks and terminals. And again, very important work related to the core network design and the terminal design as well, the testing environments. Let's look at the timelines, the 5G timelines. So it turns out that we have completed phase 1 already. And that is that happened in the summer of 2018. We released release 15, and that was the first step towards 5G. But interestingly, it is not yet 5G compliant as per the ITU requirements. So we still need to do a lot of work, and that's being done. And in December 2019, we hopefully will freeze then the next release, which will then be submitted to the ITU for approval. And if the ITU approves that, then we will have finally a proper 5G system up and running.
Now let's do a little bit of gossip to finish this off. You won't hear that too often from anybody. Let me talk a little bit about 3G. So people think 3G has been really a very difficult process to push through. In reality, it was Qualcomm, an American company, which came to the table of these standards and said, look, this is a working prototype. And everybody thought, wow, this actually works. Let's standardize that. And the rest, as they say, is history. Was it the better system back then? We don't know. Well, actually, today we know there were other systems out there which in theory should have been better. What else can I talk to you about? Wi-Fi. I worked for a big operator for a while, and I can tell you that Wi-Fi was something the operators did not like for a very long time. And a lot of the engineers sometimes went in to look on what Wi-Fi standard was doing and maybe even slowing it down. Shh, don't tell anybody. Now, the other thing is all about 4G. A lot of times you will see on your mobile phone, hey, there's 4G, a good connectivity. In reality, by standards understanding, you not always have a 4G system. 4G is if you really get a certain carrier aggregated bandwidth, which is not always the case. So it was more of a marketing gimmick to start with. I believe as of today, almost everybody has a 4G system, but it wasn't always the case. And a final little bit gossip about Narrowband IoT. That is an exciting technology to connect all these sensors on the planet. And that was a technology which wasn't planned to be done until 2021, 22. And suddenly new technology emerged like Sigfox and LoRa, and everybody is like, hey, we don't want to lose that market opportunity. So the big boys in the industry started to design a connectivity technology which would allow us to connect all sensors in the world. And that is today's Narrowband IoT. So a little bit of gossip from behind the scene. If you want to know more, just get in touch with me.
Welcome to an exciting project.